My name is Hideyuki Shimonishi from NEC, and I'm a leader of this Trema project. Today, I'd like to talk about Trema. What is Trema? And then do some hands-on stuff. So actually, this is an old program of this tutorial session. And actually, it says that here, testing, debug, and hands-on Trema meaning. So you may think that Trema is something for testing and debugging. Oh, really? Or if you know something about Trema, you may think that Trema is the open flow controller. Oh, it's yes and no. So what is Trema all about? So this is a first thing is about Trema that I want you to get to know today. The first one is what's Trema. So let's think about a day of an engineer. He gets up and he sets up the environment in the morning, and then he do some coding in the early afternoon, and then debugging. Right. And then this schedule is scheduled for a week. He do the coding on Monday, and the debugging Tuesday to Sunday. Right. And then for a year, this is a New Year's Day for the coding. Right. So now you may know that our objective, that is to improve the productivity of all open flow development processes. And it's easy to get started, and then easy to develop various applications on top of it, and then easy to debug. So otherwise, my colleague would insist on all the excuses, like, I'm not a serious programmer, or it's variations, or I like to study algorithms, or, well, NST is okay. So honestly, yes, what we want to do is to motivate those people to try SDN. And the productivity is our key message from the Trema team. So this is lessons learned from our previous experience before I go to the Trema. And actually, we have been developing our own open flow controller for about 4 years or longer. And I get lessons, many lessons learned from the ones. And our old controller called Helios have very nice features, like it has the abstraction layers, or it has the distributed state management, and all of that. And one day we have developing an efficient multi-path calculation algorithm for hundreds of millions of flows for us, sake of demonstrations. And then, we have to debug the applications, of course. But after that, we really noticed that we need to modify the abstraction layers to handle such, large number of sessions, and then for the high performance. And then we have to debug the abstraction layers. And also, we noticed that we have to, modify the core part of Helios and then modify it, and then debugging it. So this was a start of, endless iteration of application development and abstraction layer development, and then, core, so forth, so on. So if someone looks at a controller, there is a spectrum of diverse requirements for controllers. It may be used in research network, office network, data center network, or care network, which have very different data consistency requirements or scalability requirements. And then you may use a static or dynamic for pushing, or micro flow, aggregate flow, and so forth and so on. So what we have learned is that, and what we are thinking is that abstraction layers should be designed flexibly. And maybe abstraction layers would be co-developed with applications rather than co-developed with controllers. And then here is another lesson learned from our experiment. When we look at the controller and then controller software development, it is only a part of a big iceberg. Underneath the water, we do some debugging, we do network setup, and traffic generation, diagnosis system, and then everything we have to take care of it. So our scope should not be limited in the control development, but the scope should be wider. This is that everyone can think of, but we really think about everything. So if we had a seamless integration of operation and state monitoring among the controllers, applications, switches, hosts, and etc., it will greatly reduce your labor in your development. So what is Trema? Trema includes a core part of the controllers, open source controller libraries and the core modules, and also it will include developing environment of the network and the host emulator, debugging tool, and etc. And then all these components are controlled or managed by our operation environment. And then on top of them, you will develop your own controller using Ruby or C, and you may develop your own abstraction mechanisms and high-level APIs, or you will get some modules from elsewhere. And then these one goes as an open source controller. So now, what is Trema? Trema is open flow programming framework, I should say, for Ruby and C, and it's in GPL too, and then you can get your Trema source code from the GitHub. So the second one is high productivity. Again, I want to emphasize that our design goal of Trema framework is to improve open flow development productivities. So our motto is the run it quick, write it short, and then fix it easy. Again, run it quick, write it short, and fix it easy. Do you remember that? So go to the run it quick. When I start a Trema from scratch, I will build Trema, I will design my controller, and then I will set up the environment, and I will test, and then go to the production environment. So Trema supports all these flows very quickly. So how quick? Let me show now. Now, okay. So to build and install Trema is very easy. You have to type these 3 lines of code. The first one is you get the dependent modules like ZCC, Make, Ruby, or other stuff, and then you will grab the source code of Trema, and then expand, decompress it, and then just type build RB, and then that's it. And then with this, you will get Trema installed, and you will get network environment and operation environment, so forth and so on at the same time. So there is no other configurations or no other setting is needed. It's really easy. So, and then now I don't do this step because it take a minute. And then now suppose that this Trema is already installed. And then next thing you do is to build your own controller. So this time I will get the controller from the examples like Trema and source examples, repeater hub, and then repeater hub .rb. And then copy here, and then now you'll get a repeater hub controller. And then maybe I'll do some modification. Here is code, very small, and then it defines a handler for packeting. So this handler is called when the controller gets the packeting, and I'll take some additions like info is displaying something. Then it gets packets in from the switch, and then I will send that the data path ID to X, hope it works. And then that's it. Now I have my own controller. And then next thing is to set up a network environment. We do not use Minnet, but we have own network emulator installed. So here is a configuration file. It says that we have a vSwitch having the DPID of DirectLC, and we have 2 hosts having these addresses. And then we have link from host to switch and switch to host 2. So now we can run Trema. Just Trema run, and then repeat the hub that I have made it now, and then option C to specify the network configurations. Okay. I think it's working. Oh. I'm sorry. I just, Okay, now it's explained. Okay, now it's running, and then I can send a packet. Trema send packets from host 1, host 2. Oh. Or I can send more packets and packet KTS 10 and then PPS 10 packets per second. Right, and then we can see the status. Trema show start and host 1. So it sees that it sends 11 packets in total, and then see host 2. It says that it gets 11 packets. So now you confirm that the controller is running correctly, and then you will set up your production environment, and then have switches, and then connect them all, and then you will go to the production environment. And in that case, you just run Trema without network configurations, and then Trema will wait for the switches to be connected. So it's pretty easy. So you can easily develop your open control and then test it, and then go to the production environment. So let's go back to the slides. So, and the next thing is write is show. And actually, this is a sample code just I show you. That is a repeater hub. And actually, we have carefully designed that the code can be written very short, and then SAS for it is easy to maintain and then to read it. And it defines a repeater hub class, and then when it gets packet in, it will send a flow mode to flood the subsequent packets, and then it packets out the packet just it got. So it reads very smoothly like a suit code, but actually it is executable code, and then it's very simple. And actually we have carefully designed the APIs like coding by conventions or synthetic sugars or default options, and then all these techniques are used for the API for Trema. But I will not cover the details, but I will show the pointers for another set of tutorial slides, which you can follow these kind of things. You have Ruby? You have C? Thank you, you're so very honest. And actually, Trema provides a libraries for both Ruby and C. Then you can choose whichever you want if you want it. So from the rapid prototyping to the production use, or for the productivity, or for performance. So, and actually, Trema C is also as simple as Trema Ruby, and then actually the most practical applications which is provided at Trema apps, or which is using our production environment, are actually written in C. And then to look inside the Trema, and then the main part of Trema is written in C, and we provide Ruby bindings. So if we use some sort of the kind of snake-like language or T-like language, we may need some volunteers to get a binding for this kind of language. And you may recall that with the network abstractions or high-level API things, and its modularity or extensibility. Actually, this is an ongoing project on top of Trema. And unlike the headers, we do not provide these kind of things with the controller. So to study network abstractions, like here is the network environment, and here is the so-called network OS. And the Trema itself do not provide high-level APIs or abstractions, but on top of it, there are a set of common function modules like topology or path are used for your applications. So maybe sort of I'm expecting that there is kind of iterative design of abstraction mechanics, and then the applications would have eventually the very useful notion of abstraction or high-level API. So for that, Trema implementations, actually these kind of common function modules and the user applications are implemented as an independent process in the OS. And then we provide a Trema messenger for the IPC between these modules for the beta isolation. So you can safely integrate your own module or third-party module into the system, or you can run or stop the modules independently. So you do some sort of partial upgrades or the maintenance of your controller. So for that sake, we are providing some sort of configuration languages that will configure the processes or modules which you are running, or the connection between the modules, or the message filtering between the modules. So with this language, you can specify your system or the multiprocess. The last one is fix it easy. So let's go back to the demo. Stop it. And then run the Trema again with network configurations. And you can send some packets again. And then maybe you can see the status. Or maybe you can see Trema dump flows of switch.abc, and then you will see the flows install the switch, or these kind of operations you can diagnose the system. And then another tool I want to emphasize is the Trema shark. When you use a Trema shark, you would declare that you use Trema shark in your network configurations, and you run Trema again. Wireshark is automatically activated to look at what's happening in the network using this Wireshark. Okay, let's go back to this slide to explain the Trema shark. And then actually Trema shark is a kind of event collector for kind of debugging operations. And then you can see the whole things, what's going on in your system using the Wireshark. Actually, as I said, Trema is a multiprocess architecture. So you can monitor every IPC between your modules using this Trema shark, or you can look at the syslog message from switches or hosts, or you can get a packet capture from network interfaces, or any text messages you can collect with Trema shark. And it has a circular buffer, and you do some sort of real-time monitoring of the states of all these things. That would be very useful for debugging. Actually, in the Trema shark, this is a Trema shark screenshot. You see, in this configuration, we have two hosts and then two Trema processes. And then you can see the packet captures here, or you can see the inter-process communications with Trema applications, or syslog message from the switch. So you can see every information in the system in a single window. So maybe it will be helpful for debugging. So this is conclusion for the architecture. And then we have network emulator here, and then we have OpenFlow control part here. And on top of that, we have a Trema DSA interpreters, which will use a configuration file or interactive Ruby shell or CLI or something to run it quick. And then you can write this short controller part. And then at the southbound, we have a logger or a Trema shard for the debugging purpose. And then Trema apps is separate the repository where we put the Trema applications. So actually, we want to share the Trema apps repository. And in there is some practical or experimental controllers developed on top of Trema. And also, there is some experimental abstraction modules using Trema. And I think it is a good starting point for developing real-world controllers, so you can grab the code from Trema apps, maybe written in C, and then you can modify it, and you can use it in your production environment. For example, there is a module called topology, and then topology sends some LLDP frames to get to know about the network topology. And then your application will call this API to get network topology. Or the flow manager manages the flow information. And your application will ask the flow manager to install the flow and to manage the flow. And then here is applications called routing switch. Also, this can be found at Trema apps repository. And then this one works as a big layer 2 switch, consists of many open switches. So like this way, and then inside of the network, it provides the shortest path path setup. So you can use this layer 2 switch in the network with loops or any arbitrary topologies, because it has the topology and then do the shortest path setup. And the another one is a sliceable routing switch. This is an extension of routing switch. This creates multiple virtual layer 2 switches or layer 2 network domains, which we call slices. And we also implemented layer 1 to 4 global ACL. And actually, nice things about this API, this sliceable routing switch, is that it has northbound API, REST-based one, for the slicing and the ACL management. So your applications, your web browser can call this API to create a slice or delete a slice, or you can attach a specific cost to a specific slice, or you can specify the global ACL there. Now, actually, we are using this sliceable routing switch with our cloud environment with OpenStack. You have a lack of cloud. You have VMs and OpenVSH and the OpenFlow physical switches. And then you have OpenStack, and then it has the Nova API to control the virtual machines, and then it has a Quantum API for managing the network. And we are providing the plugin for that, and then that will call the northbound API sliceable routing switch, and then Trema control their OpenFlow switches. So actually, they are all free software, and then you can download this, the software from this website, and then you can create your own cloud environment. The final one is tested and supported. The lessons learned from our experience is that the regression test is very important. So we are learning the regression test and the building test regularly, and then we will get a nightly building report from the system for the list of OSs, like the build on Ubuntu 11.04 is completed successfully, taking 368 seconds. Or close on Ubuntu. Close is something like regression test and acceptance test. And we are doing all kind of this testing for the many operating systems to make things healthy. And if something wrong happens, we have a flashlight, and then the flashlight becomes red, and our engineer has to take care of it. This is very important lessons we have learned. And also, if you want to get some information, please go to the Trema website, or you can call the mail. And then actually, we welcome your contributions for Trema, and then you will get a T-shirt. And then, on the t-shirts, you have let me flow. And then you look here. This is a part of Trema code. There is no big Trema logo here. And then, this t-shirt is very useful when you are writing the code, and then if something like if you have to know the packaging structure, you just look into your t-shirts. And we have a stickers, Trema powered. So I have some of them, and if you want to get a sticker, please let me know. And the system or switches or host which is using Trema should be have this sticker. Okay, so here is a team supporting this software. So if you have any trouble with using Trema, we're happy to help you. And here's some future directions and roadmap. Actually, we are going to keep updating Trema. And actually, we are using it as our research platform and then also the product platform. So we have to keep updating Trema. And for the roadmap, honestly, we have any specific roadmap and any specifying the dates. But actually, we are doing some sort of spiral development of Trema and its use cases. Like, we have some researches on carrier network that we are focusing the scalability of controller, or we have a work on the research on data center network. There, we are focusing on the integration with the IT system or OpenStack or other stuff. So when we are developing these applications, we get many feedback from this application development, and we keep developing Trema and keep updating it. And specifically, we are using routing switch or slicing routing switch I just showed. And then we have some research on high-level APIs or northbound API using this routing switch as an example. And then we are keep refactoring the routing switch to keep update the API. So we are very happy to discuss about the API with you. And then for the stronger integration with network environment, we are developing our own software switch. With this kind of switch, the system is tightly integrated with the environment and switches. So if something happens, we can diagnose the switch and what's going on inside the switch. So that will really helpful to debug the controller. And then from the CPM, you have some time for the hands-on. So I will show the alternate steps for the hands-on session. Actually, we have the self-study tutorials. So you can just follow the slides, and then no Ruby knowledge needed in advance. So you will get the files from here, and then install it. And then you will just follow the slides. So it's very easy and a self-study one. Also, we will explore the source example of Trema directory. And here, you would not even install Trema if you go into the GitHub page. You can use web browser to look at the code. There is many simple applications that use the Trema APIs, and we have both Ruby and the C samples, so you can compare the C program and then Ruby programs. Or you can explore Trema applications. And then, actually, we have Help Desk Japan today. If you get any troubles, please call our help desk. By tweeting at Yasuhito with hashtag Trema, you will get some feedback from our team for the CPM session. But Japan is now really early in the morning, so I do hope they have wake up in the morning early and then get started. Thank you.